Let's solve this chairlift problem. We need to determine the weight of the skier in chair F, given that each chair weighs 250 newtons, and the skier in chair E weighs 765 newtons. Let's start by drawing our system. Here we have a chairlift cable that runs from point A to point D. The total horizontal distance is 44 meters, split into segments of 14, 24, and 6 meters. The vertical height difference from A to B is 8.25 meters, and there's an additional 10-meter drop to point D, with a final height of 1.1 meters from the ground. Let's add chair E, which has a total weight of 1,015 newtons. That's 250 newtons for the chair itself, plus 765 newtons for the skier. And here's chair F, which we know weighs 250 newtons plus the unknown weight of its skier. Let's analyze the forces on chair E. We have the tension in the cable acting upward and the total weight of 1,015 newtons acting downward. Since the system is in equilibrium, these forces must be equal in magnitude. Now let's look at chair F. Again, we have tension in the cable acting upward and the combined weight of the chair and skier acting downward. Since the system is in equilibrium and the tension must be the same throughout the cable, we can write that the tension equals 250 newtons plus the unknown weight of the skier. Now we can solve for the unknown weight. Since the tension is the same in both cases, we can write 1,015 newtons equals 250 newtons plus WF. Solving for WF, we get that the weight of the skier in chair F is 765 newtons.